little bit of intro to, you know what, no, we'll push the intro to C# scripting a little bit later when it's actually used. And yeah, so I'll start with the magic methods. I'll pass over to Django and we'll go from there. So let me share my screen. And just so you guys can tell me, is this font good enough? Yes, no, big enough? Fingers crossed it is. So starting off, there have been a few issues with Workshop 0, which was 2 weeks ago. There was an issue that I completely messed up the ordering of the hierarchy. So the first thing, a push has been pushed onto the repo. So the first thing that you should do is pull the latest version. Let me just go into the correct one. So the first thing that you should do is git pull. And in my case, I'm up to date. You should have some updates. They will be applied, assuming you haven't edited the scene too much. But I'll briefly explain what the edits were. In your main menu, under Canvas, we used to have a UI root object. So we used to have a little object here called UI root, and button, text, and panel were parented under it. In this case, the panel doesn't scale properly, especially not in the actual build of the game, the final game build. So to fix that, all that's necessary is to reparent all of the UI elements to the canvas and move the main menu manager script onto the canvas as well, and then set it up there. At that point, the panel will scale properly, everything will be fine. But that's the only outstanding issue we had since Workshop 0, I think. Cool. Actually, to be fair, we didn't cover building, I don't think, so I'll quickly do that as well. So once you're finished with your game and you've played it, you've tested it, and it runs just fine. Well, in our case, it doesn't do much, but once you're finished, you can go to File, Build Settings. So also can do Control-Shift-B, and you can add scenes to the build. Here, in this case, you want to make sure that main menu is at build index 0. It's at the top of the list because you can reorder these things. So make sure the main menu is at the top of the list. This means it'll be the first scene that is started when your Unity game starts. So once you've organized it however you want, making note that you can include scenes into it from your assets bar here. This means whether it's actually included in the build. So you want all of your scenes to be ticked. Once you've finished with it and you finished messing around with any of these settings, you can click build. It'll take you to this little file selector where you can select which folder you want to build in. In my case, I've got a UTP, Unity Tutorials Project build folder. Click that, select, and then it'll go off and start building. It might look like it's not doing anything. Just give it a minute and it should, in theory, eventually pop up with a little build. Oh, there we go. It'll do some stuff. Once it's finished, we can open up a folder, local C, git, Unix, and go to the folder that you created. It'll also open it. I completely forgot that it opens it. Let's just ignore that. So it'll open up the folder. You can double click on your Unity Tutorials Project exe, and it'll bring it up, right? And then you can start, and it all works just fine. If we haven't got closing, so please bear with me. Technical difficulties. That's the errata from Workshop 0 out of the way. So actually, starting on this week's workshop, we can probably close the main menu for now. Load scene, unload scene. So this week, what we start off by, in my case at least, git branch workshop 0. This is 01. Create a branch. So list, it should be there. Oh, I forgot to move off of workshop 0 branch, but move on to the newly created workshop 1 branch, and and then yeah, you're ready to go. So the first thing that we're going to be covering are, or rather redoing really quickly, are the magic methods in Unity. So assets, scripts, and we're just going to create a dummy script. So magic methods. Name it whatever. Oh, open it up. I thought I had opened Visual Studio before. Yes, please. Sorry about this delay. Cool. So once it's open in your text editor, get rid of all of the cruft that's in there before, which, let's face it, we don't really need. So you're just left with an empty class and the using Unity engine. So just to recap, the methods that are available in Unity, or the main ones that you're going to use very frequently, are onEnable. There is, what else is there? There is awake. There is start. There is update.
Sorry, Mikolai, for interrupting. Someone is asking if you can zoom in a bit.
Oh, yep, I've forgotten to also zoom in here. Is this much better? This should be much better. This was what it was last week.
Yeah, this is better. Thank you.
Yeah, I managed to zoom in my command console, not Visual Studio. My bad. Hopefully it's better now. So there's update fixed, or rather fixed update. There is also, so we've got onEnable, onDisable, and onDestroy. Most of these names quite self-explanatory, right? onEnable, this will run whenever the Unity object is enabled. So that's whenever it becomes active in a scene. For example, if we go back, oh yeah, because that's to compile. So this cube right now in the inspector, you can see that it's active, it's enabled. Whenever it becomes enabled, so when we click this, that's when that event would fire. And you'll see that because we'll add a little debug.log. So yeah, let's just call it object enabled. Object enabled. Awake, this again, this is called before any of start, update, fix, update, before any of that is called. So this is where you get references to components. For example, if you had a rigid body reference, say, you don't need to know right now what a rigid body is, but say you had this, you want to assign it here. So in awake, you would want to do get components of type rigid body. This is where you want to make your get component calls for the most part. You'll see when this is object woken. Start is then called after all awake methods have been called. So you are the first start method will only get called once all awake methods have been called. This is yeah, let's just add it there. This is where you would do something like rigid body dot is kinematic equals true, because you will know that any custom rigid body awake stuff has been done. Rigid body doesn't necessarily have any, but this is where you'd interact with your own scripts and where you'd assign variables, public variables on your own scripts or third-party scripts not made by Unity. Update, this is just every frame. Object updated, this will happen quite often. Fixed update, very similar, except that only happens for physics updates. So that's usually every 60th of a second. That can be configured. So fixed updates. And onDisable is the counterpart to onEnable. So if we go back to here, whenever this gets toggled off, so right now, that's when onDisable will be called. Oops. Object disabled. And finally, onDestroy is basically called whenever this gets deleted from the scene. We're not going to be using that, but it's very useful to know it's there, especially for cleanup code. So if you have some custom variables or other custom state that you use that you need to clean up when the object is destroyed, you make sure to add it both on the, basically put it in here and it'll get cleaned up. So object destroyed. So we don't need this because this is just an example script. we'll head back to the Unity editor, we'll re-enable our cube, and we'll put the magic methods script on here. And we'll save the scene, and we will start. In fact, I'll open the console before we start. Yeah, that's from our build earlier. You're going to see a whole bunch of stuff. We're going to collapse. That collapse is a really useful feature of the console, by the way. It'll basically merge identical things, identical console messages. So we see that first the object was awoken, then it was enabled, then it started, and then fixed update and regular update happen very frequently. So if we go into the cube and we toggle it off, we see that first of all, fixed update and object update have stopped, and that's because it was disabled. And then if we turn it on again, we'll see another enabled message has been called, and these continue. If I delete it, object disabled, object destroyed. So that was just a really quick demonstration of the different Unity methods that you have available. Some of the Unity methods that you have available, not all of them, there are others. And we're actually going to get onto a few a little bit later. So because this magic methods thing was just a testing script just to show you what it was, it's not actually necessary. So you can go ahead and delete it. Yes, script magic method, we can delete that. Yeah, so that was the first part of the workshop. I'm going to hand over to Django now, who's going to do movement, if I'm not mistaken.
Yes, thank you. Well, I'm going to cover some theory about rigid bodies and colliders, and we can make our cubes collide. That's really fun. And then we will cover movement and how to move a cube around. So that's very exciting. So let me just share my screen. I should also see my Unity editor. Is this font good for everyone? I hope so. If not, tell me. So yes, rigid bodies and box colliders or any other colliders. So rigid body just brings physics to any body. I'll see. I'll make a demo. So I selected my cube, and it's very simple. Just add a component. I have it already selected, and then you just rigid body. And then you added a rigid body. Feel free to do this along, because we're going to use this rigid bodies and box colliders for later in the tutorial as well. So yeah, and now if we press play, if I can do that and not have the zoom thingy in the way, go away. There we go. So if we press play, then the rigid body falls down because, well, now it has physics, right? So so far straightforward. And then you can see in the rigid body, you can like change its mass or the drag or gravity and stuff. So those are rigid bodies. And rigid bodies can either be static, kinematic, or dynamic. And in the show notes, no, not the show notes, the script for this tutorial, there's a YouTube video linked that explains perfectly what the difference between static, kinematic, and dynamic is. But just for a quick reference, a static object doesn't move. It's just static. A kinematic object can move, but it cannot be moved by other objects. So it would be really nice for having like a platform in a platformer, for example, so that it moves around, but if you hit it, then it doesn't like flow away or something. And then finally is dynamic, and that's the one which we will mostly be using. Dynamic rigid bodies, they can move other things, they can be moved by other things, and they collide with other things as well. So this is a rigid body. And you can also have rigid body 2Ds, for example, and this is what you use when you have a 2D game, which we are not, so we'll use a normal rigid body. Now you can see that there's a box collider here, right? And if we zoom in and press on this little icon here, we can edit the collider. And then you see like these different things. And as you see, like we can edit the box of the collider. And this just means that whatever the collider has can be colliding with other stuff. So if we make this collider tiny, then the cube won't collide with anything, because well, it's the cube is just like a rendering. It is the box collider that the physics will interact with. And you can also have a spherical collider, and that is just a sphere. So if we just edit this one, you can see there's a sphere here. So this would be nice for like having a head, for example, or like some other fancy model, which we'll cover in a later tutorial. For now, we're just going to use a box collider. So let's remove the sphere collider. All right, so now we have a rigid body and a box collider. So let's see that in action. To do that, we're going to create a platform first so we can see two objects colliding. So we're just going to right click, create empty. We're going to call it, oh no, we're going to create a cube, my bad. No, go away. There we go. We're going to create a 3D object, a cube, and we're going to call it platform, or you can call it ground or whatever. And we're going to make the dimensions 10 by 10. Yep, you see now we have a nice platform. This we can reset to 0, and we just have to drag it down like by -1. All right, as you might see, it's very confusing to distinguish between the cube and the platform. So what we can do is we just apply a material to it. I'm just going to create a new folder for materials. And in there, we're going to create a material. So you go create, what is it? Material. This can be the platform. And that can have a color of what you would like, gray. And then you can simply just drop this into the platform or on the cube. Let's do the platform. And we can do the same thing for the cube. So this just a cube material. And this can have, I don't know, let's make it, no, blue. Yeah, blue is nice. And we can drag it to the cube. So now we can see that we have a cube and a platform. So our platform currently has a box collider because Unity is very smart and it applies a box collider to every object. But let's just disable this for now and raise our cube a bit. And now what will happen is because the platform box collider is disabled, there's no box that can collide with our cube. So if we press play, then the cube will just fall straight for our platform. As you can see, it just fell straight down. And if we turn our box collider on, then it will collide with the platform and it will stick there. So that is very nice. And similar here, if we turn the box collider of our cube off, then it will just pass through because while the cube doesn't have any colliders, so it can't collide with anything. So let's leave it on. And similar, you can just duplicate a couple of cubes and stack them on top of each other. And now they all collide with each other and they fall and interact. I forgot one, but yeah, it's very nice to play one with this. Let's not have too many cubes to make it too confusing. All right, so this is box colliders and rigid bodies. There is a small thing that you can do for collision layers. So as you can see here, there's like a layer menu. So I created two layers called platform and layer, platform and player. You can create new layers here very easily. Let's not do that now. So this is, we can assign this a layer for player, and then the platform can have the layer platform. And now if we go to the project settings and edit, and then in physics, and we scroll down, we have a matrix for the collision layers. So right now everything collides with everything, but then as you saw, we can turn off the platform and the player collision here. And that means that these collisions get ignored by the editor. So if we close this, then the cube should just fall straight through because one is on the platform layer and one is on the player layer, as you can see. So that is not what we want. So let's turn it back on. And this is very useful if you want, for example, you can only interact with like certain enemies or maybe certain like background objects or stuff. So yeah. All right, let's get to moving our cube. We can put our cube back to 0, so it stays on the ground. And now what we're going to do is we're going to create a movement script. So let me just go to scripts. And we right click, create new C# here, script. We can call it, what do we call it in the tutorial? Player movement. All right, and we open this in Visual Studios. Here we go. All right, so weird that everything's so big. We can delete the random stuff here. All right, so what we're gonna do is we're gonna reference our rigid body through the cube, and then based on our vertical and horizontal axes, we can direct the cube around the scene. So first, we need to add like a line before the public class, and it is just to tell what's it called, Unity, that we require a rigid body in the script, because without a rigid body, then we couldn't use the script. Type of, and it's going to be a rigid body. You don't have to have this. The script works without it as well. It just looks more professional, and for someone reading the code, it can be like, oh, the script needs a rigid body. Nice. So we need to reference. We're going to create a private rigid body. We can call it rigid body. And then we have, we need a variable for speed. So we're going to create a serializable field, and it's private. We can make it a float, and we can call it base speed. So this will just influence how fast the cube is going to move. I'm not sure if serialized field has been covered before, but just to recap, it makes this variable base speed. That means it can be changed inside the inspector. So if you didn't have this line, then it's a private, so it cannot be accessed from outside the class, and then you wouldn't be able to change it from inside the inspector. Now, if you add the serialized fields, you can, if we go back to the thing, you can change it from inside the inspector with like a little slider. So that's really nice. Okay, I just been told we should name this to player body. Right. Sorry for this. Okay, let's move on. So next we need two other private floats, and these are for getting the inputs from the x-axis and the z-axis. So we can just call them x inputs and z inputs. Don't worry too much about this for now. We will cover why we need those in a second. I think we have to initialize them, so we can just set them to 0 for now. All right. Cool. First things first, we need to call the awake methods and initialize our player rigid body, because right now we just created the reference, but we haven't connected the reference to the script. So you can just say player rigid body equals get components of rigid body, and this is the syntax. So what this does is just it goes to the object that the script is attached, and it finds the rigid body, and it puts that rigid body into the player rigid body that we created here, so that we can use it later on. Nice. Now we go into our update method, and what we do here is we're gonna get every, so update is called every frame. So every frame we're gonna get the input from our horizontal and vertical axes. And Unity has a really nice mechanism for that, which is getting the input from the axis. We will call that, and we set it equal to the variables that we created earlier here. So we have x inputs that is equal to input.get axis. Here we go. And we want the axis for horizontal. And we do the same thing for z inputs. So we call inputs get axis vertical. Now, when you use the vertical or horizontal axis, the script will recognize that and put those values into x input and z input. You might be asking where this horizontal axis is coming from, and you can easily check that in your project settings. Let me find it. Input manager. No, here. In the input manager, you have the axes, and as you can see, there are a bunch of axes here, and there's the horizontal and the vertical. So let's just see in the horizontal. This is the name that the script is looking for, and you can see like it uses left and right and A and D. So if you have the WASD, so A and D is up and down. If you change this value to like E here, then that will be affected inside the actual gameplay. So let's just keep them at the usual values, and you can have for vertical as well. So you can just play one of this. But this system is very neat for us to use in the script. As you see, there's like lots of different events here. Like fire one is like the left mouse click. So this gives you a lot of access to play with in the game. For now, we're just going to use horizontal and vertical, so we should be fine. Nice. Then we move on into our fixed updates, and because we are changing the physics of the cube, well, we're not changing it, but we are using the physics of the cube. We need to use fixed update because update would just call the cube too many times without actually changing anything. So we use fixed update, and this is where we actually move our body. So to do that, we need to have a relative position first. So we can get the position of the cube and say, well, you need to move like every fixed update, you need to move like a tiny amount to whatever we want to. So in order to do that, we create a vector 3. This will be the relative position delta. There you go. And this is, after every fixed update, we add this to our current position. We'll get to that in a second. So our relative position delta is going to be our x inputs times our transform dot height. And this just means the transform is from the cube. So because this script will be attached to the cube, it will get the transform of the cube. The transform of the cube is the values here, the transform values here. And y just means the axis, like the direction it is going to. And we add this to the z inputs times transform dot forward, because we're going to use the z axis to go forward or backwards. I hope that makes sense. All right, and then we have to multiply this by our base speed, because otherwise it will just go constant, very slow or very fast, or we can't change it. We could just say here times base speed, but that will become a really long message, so we can just go into the next line and we just say relative, where is it here, times equal base speed. There we go. And we need to do one little thing more, and that is to multiply this whole thing by time dot fixed delta time. And this is because, well, we call this fixed update like multiple times per second, right? So if we didn't multiply this by the fixed delta time, that is the time that has passed since the last call of that frame, then these values would be too huge. Because x input and z input will be values between 0 and 1, and the transform might be like really huge. So if we didn't multiply this by time that's fixed at the time, then the values would just be unhandleable basically. And because there's such a small time frame between each fixed update, this multiplication with time that fixed at the time cancels that out with the fixed update calls. I hope that makes sense. Feel free to have more actions, or just try it without using time that fixed at a time and see how messed up it is. So yeah. And finally, we just move our widget body, and Unity has a really nice function for that. So we just call our widget body, and we can say move position, and then we have to give it the position where we're going to move to. And that position is just going to be the current position, so let's just transform the position plus our relative delta position. This line should be straightforward because we're just moving from our current position and we're adding whatever we calculated above. All right, and now our cube should be able to move around. So we save this and we head back to Unity. Now let's wait until it has loaded. And now we go into our cube in the inspector, and we can drag our player movement into the inspector. Here we go. So you can see the inspector, and you see base speed is equal to 0. And that is because it is serializable, or the serialized field. So we can just set it equal to 5. I hope 5 is a good value. And we should be able to play and use our keyboard to move the cube around. So let's see. And as you can see, it moves around. So Yay. And if you go off the edge, it falls off. Yay. You can play around with the base speeds. If you put it to 0, well, then it won't move at all. If you put it to like 100, then it will go really fast. I will let you play with that. That is it for the basic movements. So we can move left, right, up, no, left, right, forward, and backwards, and any combination of that. And next, we're gonna do the jumping, which Nikolai is gonna cover. I'll just go over the questions really quick if there are any outstanding questions. So
how does transform.right work?
So transform.right, it's basically using the right axis of the cube. I'm not really sure if I'm explaining this well, but like in transfer to forward, it's more clear because you can go forward and backwards. But transfer to right is just the direction that the transform is pointing to is going to be the right. So, well, x input is the variable that we get from the input manager from here. Then we just need to multiply this by the direction of, which is right, of the cube. So Unity does all the rest of the magic, kind of. Yeah, I hope people get that. Just try and don't do it with this and try and play it and see what happens. Or like just say, I don't know, you can do forward here as well and see how it just goes forwards. And there's no left, for example, as similar as there's no backwards. So it is either forwards, right, or I don't know the other scale. But yeah.
I think it's up. I think the other one is up.
Yeah, the other one is up, exactly. So you can just play around with different values of this and see what they mean. So yeah, these are just the direction of the cube, basically.
Okay, so I'm going to be handling jumping now.
Cool, I'll stop sharing and I'll be back later. And,
okay.
How do you stop sharing? Oh, here, stop sharing. There we go.
Awesome. Let me share my screen real quick. You should all be able to see that. Awesome. So we're going to be doing jumping right now. So this is going to go into the player movement script. So we're going right back to where we were. The first thing that we want, so what it is jumping, when the player hits some key, we want the game object to just go up. We want to apply some kind of force to the object. Since we want to get player input, that obviously has to go into update so we don't miss any key presses. So right now, okay, so the naive way of doing this would be if input dot get key down, and then we provide a key code. So key code dot space. We would, do the jump, right? If I can spell. This is the naive way of doing it. However, it's not ideal because one, if you want to change the key, you have to go down into the code and do that. You have to actually replace this. If an artist who doesn't feel comfortable with looking at code wants to say really quickly remap a key, it's not the best. And also a better way of doing input is going up to the top to where our variables are and introducing a new serialized field, private key code, and this will be player jump key. Let's call it that for now. If we think of jumping, it also needs, we're applying some force to a game object, so that we might want to be able to specify how strong that force is. So that's another serialized field, private float jump impulse, because this is an impulse force. Now, let me move Firefox. Geez. The difference between an impulse force and a regular force is that an impulse happens in one instant, and well, I don't need to necessarily explain it now because we're going to see a little bit of it later. So anyway, going back to our input.get key down, because we've shown this, we've declared this player jump key. Here we just do player jump key, and then here we might want to oh no, I've forgotten another thing. So currently we're in update, right? And update happens as many times per second as it can. Unfortunately, since we're doing jumping, we want to interact with the physics, and physics only happens 60 times a second. So by putting physics interaction code in update, you are wasting CPU cycles because you're changing fields when they're not the changes aren't going to be noticed until the next 60th of the second anyway. So going back up to our jumping, we have to add another field. This time we don't want to serialize it. A private ball should jump. And this will be used to basically store a value that whether we should jump. And then we're going to use that later in fixed update. So here we just do should jump equals true. Now, you might think, well, wait, this is just assigning something multiple times again as well. And yeah, you're right. However, because it's a local variable, it should, in theory, be slightly faster and waste less time than interacting with the physics engine, which is a call across a language barrier. Or at least it might be. I'm not quite sure. It depends on how Unity's implemented it. But this is okay because this is small and this is local to the script. It's quite fast. Changing something on a rigid body isn't. And now that we've got our input from the player, we need to go down here and we need to actually apply it. So if should jump, what do we want to do if we should jump? Well, first we might want to turn it off so we don't jump infinitely, right? So should jump equals false. And we also want to do player rigid body dot add force or relative a force for now. And then we want to do an up force, so new vector 3. And because this is up, we want 0 jump impulse, 0. Yes. And then add a comma, and you see how now IntelliSense has shown a force mode. So here we want to type force, if I could spell again, force mode dot, and you've got a choice between acceleration, a regular constant force, impulse, and a velocity change. This is an impulsive force. We're applying it in one instant. We choose impulse. We save that. We go back to the editor. We wait for it to compile the C# again. We go back to our cube, which is where our player movement script is. And now we see 2 new fields. We see the jump impulse and we see the player jump key. For jump impulse, just set it to 5 again. You'll know if it's too high a value, if it's too low a value. You'll see that when you play the game. And here you get to choose which key it is. This isn't the best input, to be fair, because you can see that there's a lot of keys and you can't really see it, but I'm not scrolling right now. I'm unable to scroll. So you're going to have to use the up and down arrow keys to go find the thing you're looking for. I might have missed it. Where's space? Oh, someone said something in the chat. You know what? I'm going to go back up to the top. I might have missed it. Slash semicolon ampersands. Oh, come on. Oh, there we go. Space. We found it. It only took us a little bit. So save the scene and enter play mode to test. So if we press space, it jumps. However, what happens if we press space many times? We're gone. It's flown away. It'll come back down eventually. We might be able to see a shadow of it as it comes back down, unless it's really gone far. Oh, there it is. It's back. What you might have also noticed is that I don't know if right now its rotation isn't frozen, so it can rotate really weirdly. For now, let's disable it. So we go into rigid body. Actually, first we exit play mode. We go to rigid body. We go under the constraints tab, and we're going to freeze the rotation in all 3 axes. What this will do is it'll now mean that this rigid body is now no longer able to rotate in either X, Z, or Y. And so now we can, without fear, press space and fly and float, and we won't be thrown off axis. Exit play mode. We need to fix this because this is an issue. This is a bug. The way we would fix this is by doing something called grounding the object. I see that there's a lot of chat. So are there any questions? Because I've now got a little bit of time.
No, there are no questions as far as I'm aware.
Okay, awesome. So we're going to start by creating a grounder. So we go into scripts, right click, so assets scripts, right click, create C# script, name it grounder. Pardon me, and open it up in Visual Studio. Get rid of all of the previous junk except for using Unity Engine and the class. If we think about a grounder, what are we going to need? How are we going to know when the player has touched the ground? Previously, when we had introduced rigid bodies, we'd mentioned colliders. Django had mentioned colliders. They're not only useful for detecting collisions between physical objects, right? So whenever, obviously they're useful for having the cube, the player, know that it's touched the platform. What you might have also noticed is this little is trigger switch. If we set is trigger, it'll fall straight through, right? Because now it's no longer registering a collision, it's registering a on trigger enter. You see, the platform has entered the player's trigger collider, and so that's sent a message to the player, but it hasn't registered a collision in the physics engine. We're actually going to use that, so remember to unset it. We're actually going to use that to detect when the player has touched the ground platform. So in the cube, you're going to want to right click on the cube in the hierarchy, create empty, and we're going to call this grounding. Yeah, let's call it grounding object. That seems like an appropriate name. Or you know what, better yet, we're just going to call it grounder as well. So cube grounder. We're going to add a component, and this will be a collider, a box collider. We're going to set it to be a trigger. I'm also going to go into scene view real quick, and I'm going to zoom in, right? So we can see the wireframe outline of the collider just faintly. What you're going to do is set this it's scaled to 1.1 and not the y and 1.1. So you see that it overlaps the box briefly. See, in all the axes, it's slightly going outside of the box because it's 10% wider in the X and Z. In the position, you're going to set the position of this collider to minus half of the height of your player. So in the cube, this scale is 1, it's 1 unit. So we're going to set this to minus 0.5. But then we're also going to flatten it. So this will be, you know what, we can get away with something that's quite thin. You know, that might still be a bit too thick. So let's do 0.05. That's quite thin. That'll be a quite you know, high quality resolution. We won't be allowing the player to jump when they're still very far off the ground. That's what we want. In fact, you know what? We're going to, instead of putting the scale on the collider, we're going to put the scale on the game object instead. That seems fine. So we've got this. Now we're going to also drag our grounder script onto here, just so we don't forget later. We're going to save the scene, and we're going to make sure to set the box collider is trigger, to add your grounder script, and to edit the scale and position of your grounding collider box. Head back to Visual Studio. Initially, all we're going to do, actually, you know what? Okay, first, so create a private void on trigger enter, and a private void on trigger exit. For now, we're just going to do debug.log left ground debug.log touched ground. Awesome. We're going to head back to Unity. So save the script, head back to Unity, and oh, here's another thing that I had forgotten. So the platform here, set the layer to platform, and in Grounder set the layer to platform as well. It'll just keep them nice and separate, like logically in your head. So we've set both of these to the same layer, and now when we play, let's open the console. When we play, what we should see is, oh, okay, it's touched ground, and then we left ground, we touched the ground again, we left the ground again, we touched the ground again, right? You see that whenever the player jumps off the ground, they first leave the ground, then they touch it again. Close exit play mode, head back to your Visual Studio or whatever your text editor is. And now we're going to type in the magic, for now, magic words, action. Oh, no, that's not what we want. Public event action. Oh, no, go away. Here's what we're, so here where you've got your using system. IntelliSense is just not allowing me to do anything today. Collider. And we're going to call this touched ground. And we're going to do the same. Event action collider. And this is going to be called left ground. Self-explanatory names are always nice. What are events? A good analogy for events are publishers of magazines and subscribers to magazines. So a publisher will frequently be pushing out new editions of magazine, right? So maybe you've got a weekly magazine, maybe you've got a monthly magazine, but all the time, or even just randomly, the publisher is sending out new copies, new editions. You as a subscriber to the magazine want to receive these updates, right? You want to know when a new edition is available and you want to get it. So you've subscribed to the magazine. You don't care as a subscriber how many other people, who exactly else is subscribed. You just don't care about that. You just want your magazine. Events are basically that. This event, this is an event. This is like the magazine. Grounder will be calling the event. It'll be invoking it. So it is the publisher. And anyone who wants to subscribe to the event to know when the ground object has touched the ground can. They're a subscriber. So in onTriggerEnter, replace debug.log with touched ground dot not dot question mark dot invoke, and you see how we've got a collider here. Well, we just pass the other. And similarly in onTriggerExit, we do the same. So we do left ground question mark dot invoke other. What is this? What the hell is this question mark dot syntax? So event, the funny thing about events is if they don't have any subscribers, they are null. So, and this is basically a shorthand way of saying if touched ground not equals null, this is what the question mark dot is equivalent to. It's a syntactic sugar for the exact same thing. So we're going to get rid of that because we do like having stuff on one line, and we're going to call this. The invoke method, by the way, isn't visible from any other class. You can only invoke a method in the class that contains it. That's quite an important thing to know, because otherwise you as a subscriber would be able to effectively push out new editions of the magazine. That doesn't make any sense. So it's not allowed. It's exactly the same here. We did the same. We've got left ground.invoke, and that basically finishes our Grounder script. So we go back to player movement, which is our general like movement stuff. And here at the top, where we had the private rigidbody player rigidbody, we're also going to include a new serializable field. So serialize field. Oh, if I could spell, that would be nice. Private grounder. Let's call it player grounder. So this is what we've got so far. And now in not in awake, because it's another thing. So private void start. Player grounder, we do love following best practices. Yeah, because this is a separate game object, we want to do it here. No, we don't. What am I saying? It's serializable. We don't want to do any of that. Sorry, I had a complete bro moment. It was not ideal. Since we're serializing, we're going to be passing this in. We don't have to fetch anything. Sorry if that confused you. So we've added the player grounder. Let's head back to Unity. So save the script, head back to Unity, open up Cube, and go down to your player movement script, and you should now see this thing called player grounder. So now we just drag grounder over here, and it'll automatically pick up the script. Really nice, really useful. Save that. And now if we play, nothing happens, right? We can still jump infinitely, nothing happens. You don't see any consoles because we removed those. But, oh, sorry, but the events that we had in the beginning, they are firing. So let's see that now. Let's see how we can see that. We're going to create at the bottom, just for now, just so we have a space to do it. Or we are getting rather low on time, so I'm going to speed up. Private void on touched ground. Or you know what? No, let's on touched ground. Collider other, and private void on left ground collider other. Okay, we've got this, and here we're going to add our previous debug.logs, touched ground and debug.log left ground. Okay, we've got that. What we then want to do is now in private start, yeah, no, not static start. Now what we want to do is player grounder dot, and in Visual Studio you can filter by events. So here we're going to assign touched ground. We're going to add ourselves. We're going to add ourselves to the subscribers plus equals on touched ground, and player grounder dot left ground plus equals on left ground. This now when we start the game component, so after we've awoken, after all game objects have awoken, it will assign ourselves to the list. Now this, if you save the script, go back to Unity, and you play, you will see that now you register events. You see, it works just as before, except now we're receiving those events in the player movement controller script. However, this is fragile. Right now, this is still fragile. Like this, now they're unassigned, and you might not get them. You might not receive the events anymore. You still do, because start is like, it doesn't happen, but you could forget. Additionally, if you destroy the object, you are going to have a memory leak, or at least there's a very real chance of a memory leak. I'm not going to make such bold statements because I'm not sure. But because you've assigned a handler, but you then haven't deassigned it, and the script will have been cleaned up, there's a very real chance that you have a memory leak there, which isn't a problem in our case, because we're dealing with one object. But it is going to be a problem later if you have many of these objects and you're using this very frequently. So instead of using the start method, what we're going to do is on enable. Right, in on enable, we're going to add ourselves to the subscribers, and we're going to copy just real quick. And on disable, we're going to take ourselves away. We're going to unsubscribe from the event. So change the plus equals to a minus equals. And similarly, in on destroy, we want to stop being subscribers, right? We want to unassign ourselves from the list. We're then going to move this around a little bit, because why not? You know what? We're going to actually leave the actual real methods at the very bottom. We're just going to have the Unity magic methods above each other. So like in one little nice block. Okay, just prettily formatted. So this is now correct code. We've added ourselves to the touching. However, we still don't actually do anything, right? We just log a message. We can still jump infinitely. The way to now get around that would be to have another private ball is grounded. And you can initialize this to false the same way you can initialize this to false. It's fine. You don't have to, but you should really. So when do we want to set this? So going back to our fixed update and if should jump, we don't want to jump only whenever we should. We want to also check if is grounded. So if is grounded, and so this is logical and should jump, then we want to jump. Then in our untouched ground, we can set is grounded equals true. And on left ground, we can say is grounded equals false. Save the script, go back to Unity, and you won't have to do anything. You haven't changed anything. You don't have to go to the inspector. You should be able to now press jump, and look at that. So I'm mashing space right now. Oh, there is a glitch. I think I might have mashed it so fast that it actually happened on successive frames before the event was called. So you have to be seriously mashing, and even then you can see it's not happening very often. I wasn't aware that there was a real bug, but you see that there was also an issue with the thing. You saw that I'm mashing right now, I stopped mashing and it still stays. So I guess, will this fix it? Just off the top of my head, it might not, but we'll have to see. No, that hasn't fixed it. Oh, it's left my mind how to fix that. The script will have this in it. The script shouldn't have this issue, but it's completely left my head how to do that. But for the most part, you can see that now it works, right? You no longer jump infinitely. Let's just double check. Yeah, and you can obviously still move. You can jump while moving, and it's all good. It all works. So whereas previously the cube would fall off the edge into oblivion, we can now avoid that. Okay, that's it for jumping. I'm going to pass back to Django so he can do some more advanced movement. Let me stop my screen share. Any questions? No. Okay, so Django, feel free to go ahead.
Yay! I can't jump for some reason.
Oh.
I don't know what I did wrong. I don't know what I debug now. But somehow let me share. Share screen 1. Yes, so I can't jump, but let's not concentrate on that now, and let's instead move on. So we're just gonna cover how to crouch and sprint. And crouching and sprinting is basically just a change of pace. Later on, we're gonna learn how to like crouch, and then the object actually like crouches, so like sprints, and like it changes the animation. But for now, we just have a cube, and the cube crouches the same way it walks and sprints, just a bit faster or slower. So how we're gonna do that? We're gonna go into our player movement class, which is this one, and we're gonna create an enum. And enums are very nice because they can have different states, kind of. So just above our class declaration, we're just gonna say public enum, and we're gonna call it player movement state. So yeah, this is creating our player movement state, and what we were gonna have in them. So we will have normal. We can also call this idle or just walking or moving, but let's just call it normal. Then we have sprinting, and this is the really fast one. And then finally we have crouching. And crouching, you're normally slower, hopefully. So these are our 3 states, and we can just call player movement state, and then it's going to return one of those object states. Then we need to have new serialized fields. So under our key code for player jump key, we want to have the same. We want to have a key code for crouching and sprinting as well. So we can just copy this line here and duplicate it twice. One, no $sign here. One for sprint key. What is wrong with my typing? And one for crouch key. Yeah, oh, come on. There we go. So this works very similar to the jumping. And then we need to have two variables that define the speed, and we can just copy the line from the base speed. We're going to copy it under the sprint key and under the crouch key. So this will be the sprint speed, and this will be the crouch. I don't like typing crouch speed. There we go. And then similar to our jumping, we only want to jump when we should jump, right? Like the should jump. So we're going to have the same thing for should you sprint or should you crouch or whatever else is there. So this, we can just copy the, where is it? The should jump. We can copy this one and do the same thing under sprinting and under crouching. And we call this should sprint and should crouch. Let's just move this up, jumping, so it's all nice and organized. And this one as well. Nice. Okay, so this is the setup. A very simple, we have covered this already. Hopefully there are no questions. Then we can move on and create, let's do that at the end. Yeah, before our events. And this is going to be a public player movement state. Remember, that's the enum, so we're going to return an enum object, not a state after this. We can call it state. And in here we get, this is just the syntax, so hopefully it's not too confusing. And this is what we should return from the enum. So if you should sprint, then you return the player movement state dot sprinting. Remember, the player movement state is our enum. Else, if you should crouch, then you return the player movement state dot crouching. Right, and finally, if you shouldn't sprint or you shouldn't crouch, then that means you're idle, you're just walking on the normal state. So if the code passes through these two if statements, we return player movement state dot normal, because yeah, that's the idle, the standards. So this is our function for finding out what state we're in, pretty much. And now the rest is very similar to what we have done before. We go into our updates, and we can just copy this code from the jumping, and we're gonna do the same thing for sprinting. So the sprinting key, if you press the sprinting key, then we should sprint, right? And similar for crouching. So we just copy this again. And we say, well, if you press the crouching key or the crouch key, then you should crouch. All right, so far so good. We just did the same things that we did for jumping. However, there's a slight twist to this story. When you're jumping, you only jump once, and you jump, and then the jump finishes naturally because physics. So this doesn't happen with sprinting. Like you have to press sprinting, to sprint, and then at some point you stop sprinting, right? And there's no physics involved in that. Like the Unity can't say if you should stop sprinting or not. So we somehow need to tell that in the code. And for that to happen, we have an if-else statement. So remember, this is the update function, so it gets called every time. So if the sprinting key is pressed, well, then we're going to sprint. And if it is not pressed, then we don't want to sprint. So we can just add an else condition here. and we say if you don't press it, then you shouldn't sprint. So we could just say else, and then you should not sprint, so should sprint equals to false. This should work in theory. However, Unity has a really nice input function similar to get key down, and that one is called get key up. So get key down is when you press down, and when you release the key, then you press it up, basically, right? So we can use this function to see, oh, when are you releasing the key? So we can do that by just saying if input dot get key up, here you go, and this will be the sprint key. Then we want to stop sprinting, should sprint equals to false. And we do the same thing for crouching, because you only want to crouch when you press the crouch button. So here we say, or you can just copy this statement here, and it's the crouch key, and you should not crouch, shall not crouch. So yeah, this is in the update, and we're just defining what state we are in. Then we have to actually implement our crouching and sprinting speeds, and that will be done in fixed update because you're changing the speed of the rigid body. So we go in between these two lines, and we'll have a switch statement. And the switch statement is calling our state method. Remember, the state method is the one we created here below, and that will just return, oh, what state are we in? I hope that's clear. And we have case one, it's a player movement state dot crouching. And if it's crouching, that's what the switch statement does. Then we want to slow down our rigid body, right? So we can call our relative position delta. So we say relative position delta times equals our crouching speeds. And then, yeah, we have to break out because it's a switch statement. Now I'm just thinking we need to move this line under the switch statement. So you can just do it with Alt and the key down, and you can move it down because we modify it here, and you don't want to modify it before it has modified with the time fixed at the time. So just move it down under the switch statements. So we break and we repeat this for well, the two other cases we have. So this is for sprinting and this is for normal. So if it's sprinting, then we multiply it with our crouch speed. And well, we don't actually need the normal because that will just be the default one because that is the normal one. And for the default one, we just want to multiply it by the base speeds. And now that we multiply it by the base speed, we don't have to multiply it by the base speed later on. So we can just delete these lines and the case default. Yeah, there we go. So that's it. Just a quick recap. We have a switch statement, and that will apply our different speeds. So base speed can stay the same, crouching speed should be smaller, and that will get affected relatively to the code. So now, if we save this, head back to the Unity editor, wait until it is loaded. I see some questions. Nikolai, I guess you're on it. And we press play. Oh wait, first we have to set our keys. That was stupid. So if you go to the cube script that we have earlier, so our sprinting key, what is used for sprinting? I don't know, X. And crouching is C. That doesn't work. Where's C? Yeah, C. There we go. And we can set sprinting speed to, let's say, 10. Why does it work? There we go. I don't know what I did. And crouching speed to something like 1 or 2. And we play now. You can see it is now moving normally. And if I hold C, it is moving much slower. And if I hold X, it is moving also very slow for some reason. Oh, there we go. So that is how you sprint and how you crouch. I hope you could follow along. But the logic here was nothing new. So any questions in the chat? Wait for people to type. So this would be something like hold versus toggle. Yeah, pretty much. So right now you have to hold it, and if you release it, then you don't sprint anymore. In the case you're using sprint crouch for the case, sprint crouch for the case. Let me check. Oh, that's why it didn't work. Sorry for that. Here we want to use, of course, the sprint speed. Thank you, Vlad. Thank you. That was not meant to happen. Cool. Let's now finish up the tutorial by just adding a tracking camera. So as you see right now, let's say the platform will be like much bigger. Then you could actually like leave the field of view. So let's say we have like, I don't know, 100 by 100 here. That's pretty nice. It isn't an RPG now. It's or to pitch. So now, what if I have pressed the wrong button. So now you can like leave the scene, and you wouldn't be able to follow the cube around, and then you wouldn't be able to play the game, right? So we somehow need a way to track the camera and like focus on the cube. And to be able to do that, we can do it two ways. We can do it in the editor, or we can do it in code. The editor is very easy, and it can be done in like a second. So you just grab the main camera and you just drag it into the cube. So now the main camera is a child object of the cube. So whenever the cube moves, then the camera moves as well. So if we now press play, we can see, but you can't see it on the game view. But if you look at the scene view, the camera and the cubes are moving here. You can't see it on the game view because everything looks the same. But if we approach the edge, let's just go there. So now we are approaching the edge, then you can see, the camera is now focusing on the cube, as you can see here. So this is a very easy trick to just make the camera follow. However, it creates some unpleasant things. For one is that the main camera is like hidden in this cube object now. So if you now contract the cube object here, you won't see the main camera at all. So maybe later in your game project, you want to like do something with the camera, and then like, oh fuck, where did I put the camera? And then you might not be able to find it. Another issue is that maybe you want to have some really cool like camera shots, which you need to have like some other code for. Then it wouldn't be nice that it is attached to the main object. So let's take it out again, and we're gonna create a new script for the camera tracking. So into cube, we can create a component, and we can just call it camera tracker. Yeah, is that a word? I don't know. We create a new script, create an add, and what we're gonna do is we're gonna reference the camera, and we're gonna follow the camera on the cube. So here it is. We can double click this. As usual, we delete this and this. And what we have is two serialized fields. One is a private transform. There we go. And we can call it target transform. And then the second one is a vector free, and that is going to be the offset. I will explain the offset in a second. So we have a serialized field, it's private, vector free, and we can call it target position offset. Right, and then in our update function, we can make the camera follow the target transform. So we can say transform dot position equals target position, no, target transform first, not the question mark, target transform dot position plus target position offsets. All right. Now that I'm writing this, I realized that this shouldn't be attached to the cube, but rather to the camera. So let's change that. My bad. Sorry for that. Let's wait until it has loaded. We've removed the camera tracker from the cube because we don't need it here. We need it on the camera. So on the main camera, you can track it in here because it has a target transform, and we want to follow the object, not the other way around. The other way around would be possible, but this is better because now we can track multiple objects, or like switch which object we're tracking later in the video. So yeah, another thing is if there is no, where's my, oh, 1 second, come on, thanks Unity, player camera tracker here. Another thing is that, let's say the target transform is null, like there is no camera because we died, or like the object has somehow disappeared, then the camera will be tracking something null, and that would create an issue. So we can just not have that by just checking if our target transform is not null. This makes sure that it doesn't track something that doesn't exist. Just move this in. So yeah. All right, that is it with the code. So let's just go over this. We created the tracker transform, that's our cube, and our offset. And the offset, I will show you in a second, is how far away is the camera supposed to be. So when we go into our editor, and we go to the main camera, here we go. We have to drag our cube, which is our target transform, into this placeholder, like so. And right now the target position is offset is 0, 0, 0. So that means that the camera is at the exact same position as the cube. So if we press play, you would see that we are now inside the cube, and we can move around. And this is what is used in first-person shooters. So you can just create like a gun and stick it up there, and then you have like a shooter, which is really nice, but we are not using that, and we are using a third-person view. So I'm still in the play mode, so all my changes are live. So if I change the X position, you can see that I'm moving the camera like in and out of the view, and similar to the Y, that's up and down, and the Z is backwards. So now I can just like find something that's nice, like so, or the X should be 0, maybe a bit higher. There you go, or further away. And now the camera tracks it around, and well, you can't see it in the game view again, but once we approach the edge, you would see that we are tracking the camera from outside the cube. So yeah, that's it.
Django, could you show rotation?
Rotation, what do you mean?
Of the camera. So Ivan asked if you can rotate the camera. So that would just be in the transform, right?
Oh, right, yeah. So because our camera is not attached to the cube, we can directly rotate the camera. So let's just zoom in here to the camera. So this is our camera, and this nice thingy. And if you press, let's go out of the play modes. So this is our camera, right? And if you go to the tool, what is it? The move, rotate, or scale selected object, this comes up. And now you can like move this up, we can down, and then you can also rotate it like so. That is the red circle. And then let's say like really extreme, move it up a bit. And then you can copy these values into the target position offset, for example. And then, yeah, we can play. Well, now it's set to 0, 0 again. So you have to go out, but you see the rotation is constant. So if we just go out a bit, like so, up, and then you can like rotate it. You can even rotate it like sideways, have some really weird view. Maybe that's the game. So you can do all kinds of funny things with the camera at this point. So yeah, that's how you rotate the camera. Other things you can do with the camera, you can change it to like an orthographic or perspective view. Yeah, field of view is just like how of this. So yeah, this is all connected to the camera, and we will probably explore these in a later tutorial. For now, all you need to know is that how you track the object, and that's exactly what we did. So yeah, that is it for the coding part. To just finish up, we can just well, save everything, make sure that there's no star here. As you see, the star disappeared, that means it is saved. We go to the command line, just add everything we did, a lot of new files created. We commit, and you can say, I don't know, finish workshop 01. And then let's check if we're in the right branch. We are, and then we can push. Yeah, well, you should be able to push. I'll use this. Are there any questions?
There don't seem to be any outstanding questions. Oh, Jesus, the echo. However, there was, so I remembered how to fix the bug from earlier. It's already come up. So Django used the get key up. Earlier when we were jumping, we weren't setting should jump equals false when the key went up in player movement. So you can get rid of is grounded. So in fixed update, in the if should jump and is grounded, you can get rid of is grounded equals false. And then in the update, where you set should jump, just just add it if else if get key up and set should jump to false there. Else if.
Oh.
And then input dot get key up player jump key. Yeah, because we were setting the issue was that we were setting should jump to true, and we only unset it when we jumped, which should happen the next time we touch the ground. In this way, should jump is set to false as soon as you let go of the button. That's all extra I had to say. Any questions as a whole from the stuff that we've covered so far in this workshop?
Let's see if I can jump now. Yeah. Okay, I still can't jump. I messed up somewhere. I hope everyone else is able to jump. It's some typo, I guess, somewhere. I've never paid so much attention to a Zoom meeting. Yeah. Well, I'm glad you did.
So the using system was to do with the delegate type action. So here in the events where we have touched ground, you see public event, and then you see this thing called action collider. So action is that's what's actually a using system. You see that now it's stopped being green. So you need to add a using system again. What is a delegate? A delegate is basically a function reference. So what action collider here means is that touched ground can only have subscribers who are methods that don't return and take a single parameter of type collider. That's a lot of text, but if you go onto on touched ground and on left ground in player movement, you can see that they are both methods that they have a void return, so they don't return anything, and they have a collider other. They have a single parameter called that is of type collider. That's what action means. If Django was to go back to grounder and change it, so instead of action collider on touched ground, have action collider comma int, and he saves that. If he first of all, you see that the invoke fails because you haven't passed int to invoke. So just pass like 42 or something, or 0, that works too. If you go back to player movement and on enable, you should see that now there's red, because on touched ground, the handler no longer it doesn't take an integer parameter, so it can't be assigned to an action taking a single parameter of type collider. That's the using system there. I'm sure that Django, when he was trying to follow me, I was going way too fast, wasn't explaining it well enough, and I'm sure he just made a silly little error. It'll get fixed.
I'm still trying to find it.
The fix will get pushed onto the Git repo, so you'll be able to find it. And the workshop script should, in theory, be fine. I hope that like explained a little bit about using system and delegates, because I know I didn't cover delegates at all when I was explaining events. Any other questions? We've got time for maybe a few, if anyone has any.
Jawohl.
Was ist deine Frage? What is your question, my dude? Oh, no question. Well, if there aren't any, oh no, no questions. Awesome. Just one more thing about the player movement state thing. When we declare that, you can see that it's not like the rest of the methods that we declared, right?
I'm just going to post this.
Oh, okay.
The link.
So it's not like the rest of the methods that we declared. Yeah. Thank you, Django, for doing this. You reminded me. So if you go to that workshop, there is a much more in-depth description of the different types of C# in general, right? You saw a little fragment of it. There's an in-depth explanation of the majority of the stuff that you need to know, really. The basic stuff that you need to know, and a lot of stuff that you don't need to know. Quite a lot of stuff that you don't need to know, actually, about just C#. So feel free to use that as just a reference. Just go on there. If we've gone over something badly, ask in the Discord, ask now, or feel free to just go and check. I'm sure comp 1.6. We haven't covered inheritance and polymorphism yet, but we will. We will get to that. That will be used in a later tutorial. So, comp 1.6.4.1.4.1.2 is definitely better than this for now, though. Oh yeah, so I was rambling on about the state thing. That's actually a property. So if Django, if you could go back to the code where you had the state property declared, you can see that it's slightly different from our other methods, right? It's got this get thing. What Django could also do is add a set, right? In Java, when you've got properties, you've got the specific get and set methods. So you, for example, get property name, set property name. C# is nice in that it simplifies that. So instead of having to have a get state and a set state, we can have these little get things. It just shortens the code, makes it a bit more easy to read, and it makes it much simpler to think about properties, right? Because you just access them as a variable. So for example, if Django wanted, he could go onto main menu manager.cs and he could access this public property as he would any other variable. So if he had a player object, just so somewhere in like start game, if he adds at the bottom just a player movement, that's what it's called, a player movement, calling it whatever, just a dummy thing. Oh yeah, if he shows now, he should be able to find state. No, why is it not static? Is that the issue?
Yeah, wait.
So just yeah, that's a bit of an issue. Okay, so just static is, again, that just means it's on the class. So now he should be, oh yeah, because you're using those. Maybe if you just add a really quick one line, like player movement temp equals null or something. Just add make a dummy variable here. Oh, just make it null. In null should be fine, right? Oh yeah, or you could do that, I guess. Not sure if you can cast that, can you?
I'm
just make it null. Just make it null. Just make it null. that will yeah. And now if he goes into start game or somewhere, he can do PM dot state, fingers crossed. Yes, see, you can access it now as a regular variable. You don't need the brackets. You specifically can't have the brackets, the parentheses, my bad. Now he can do, for example, player movement state equals PM dot state, and it just reads nicer. Or he can check it exactly. That's a bit about properties, which also wasn't explained very well because I forgot to mention it at the beginning. Okay, we're 6 minutes over. Any other questions?
Based on the comments, I think we did a good job.
No, okay, the collider parameter, it doesn't have to be other. For example, Django here can change private void untouched collider. He can change the collider thing to be foobar if he wanted to. Action only specifies that the type of the parameter must be collider. It doesn't care what the actual the parameter name is. In grounder, that does matter. No, it doesn't. Again, it doesn't. No. In grounder, it doesn't have to be. Yeah, exactly. I'm getting tangled up. But the parameter name doesn't matter. Only the type matters. Anything else? We're more than happy to answer.
I guess if there are no questions, we can finish up the session, and then feel free to always post in the Discord server about anything that was unclear, or if you're having problems with anything. And yeah, next week, we're not sure exactly if we're going to have a tutorial. We're working on it, but let's just say we're going to have it. And then if not, we'll update you on the Discord server. And thank you for coming, and hopefully basically see you next week. Bye, everyone.
Thank you everyone for coming. Have a nice week.